Hey everybody, welcome back for part B of this video. In the first half of the video for this section, we talked about finding areas or volumes of solids of revolution. What happens when we took an area and kind of spun it around one of the axes. These volumes that we're going to see in the next two problems are a little bit different. These problems deal with a flat surface, and we're actually going to start down here at example number 4. A flat surface, in this case it's a circle, and we're going to lift a different type of area out of that shape. So in this case we are lifting, or the engineering word or manufacturing word is extrude. We are extruding equilateral triangles out of the flat circular shape, and we're going to end up with this kind of blue gumdrop shaped volume. And we should actually go back up top to the notes section. That's here on page 3, where we learn, and you can read through the notes here, that because we are just adding up all of these cross-sectional areas, our integral is actually pretty simple. It's just the integral from one value to another, from A to B, of that cross-sectional area. So if we can find the area of each cross-section, then this becomes a pretty simple problem. Example number 4 that we're working on here, we're going to do without a calculator, and then I'm going to show you example number 5 with a calculator, namely Desmos, coming up. But let's focus here on this shape. So we need to find the area, or the volume will be equal to the integral from A to B, so that is -3 to +3, and we'll go ahead and sub that out. And times the area of each equilateral triangle. So we could go through and use special right triangles and find the area of this particular triangle. If you never learned the area formula for an equilateral triangle, I have that here for us. And you can take these notes when we get to the AP test. The virtual one will be able to use these notes. So go ahead and take this one, write this down somewhere important. So the area of that equilateral triangle is the square root of 3 over 4 times the length of one of the sides of the equilateral triangle squared. Well, the side length that we have here looks to be y units above the x-axis and y units below the x-axis, so we could call that 2y. dx. Be careful here, and we'll explain this in a bit. So the reason we use the dx is because we are using x values for our a and for our b. So let's do some simplifying before we dig into how to handle that y variable. So this means, oops, sorry, I had a 4 in my brain because I'm about to talk about this next piece. Square root of 3 over 4. 2y squared is 4y dx. All right, the 4's are going to cancel out, and so my volume is equal to the integral from -3 to 3 of the square root of 3 times y dx. Now, because we are dealing with a dx integral, we're not allowed, at least right now, to put a y variable in this integral. So we need to solve y in terms of x. Well, luckily, we were given a formula for this circle, and we can get y by itself. So let's do that. We'll subtract x squared from both sides. And then if we take the square root, in a couple of steps, we're good. So this should be squared. So when we put this all in, we are now going to replace the y. We're going to substitute in that square root expression. So here we go. Our volume is equal to the integral from -3 to +3. Square root of 3. So now our variables agree. We have a dx integral with an expression of x in between, or under the radical. So I'm going to pull out that square root of 3. You could have done that at any point in time. The square root of 9 minus x squared squared is just 9 minus x squared dx. And we're almost done. Now we just need to take the antiderivative. So here we go. Our volume is equal to the square root of 3 times, let's see, the antiderivative of 9 is 9x minus 1/3 x to the third from negative 3 to 3. All right. Well, now we're in algebra mode. The calculus is finished. Here we go. I have 9 times 3 is 27, minus 1/3 times 3 to the third, that's 1/3 of 27, which is 9, all right? Minus, now we're going to plug in negative 3, so negative 27 minus 1/3 of negative 27. So this actually comes out pretty cleanly. This becomes 18 minus negative 27 plus 9. And we'll just keep going. Feel free to take as many or as few steps as you like to find out that this is 18 plus 18, which means our volume is 36 square roots of 3 cubic units. So just to be really clear, we're starting with a flat shape. In this case, it was a circle. We're lifting up a equilateral triangle out of that shape and adding up all of those triangular cross sections, and we get this total sum of 36 root 3, which means the volume of this blue gumdrop shape is 36 times the square root of 3 cubic units. Cool. That is one example. We're going to take another example in the next problem, but we're going to use Desmos to help us out because the numbers get a little bit funky. You can do this without a calculator, but why wouldn't we use one if we're able to? So here we go. Here's the example. I've even given you a picture here to show you that the flat shape is not something simple like a circle. It is the region between these two curves. So let's take a look at this. We also need to know what kind of shape we're raising up out of this area, and it says we're raising squares. So let's kind of draw this picture here. We are using squares perpendicular to the x-axis. And I'm going to try and make this as three-dimensional as we possibly can. So there is a square being raised up out of the curve here. So what we need to figure out is how do we find the area of a square? Well, we do that by just taking the length of one of the sides squared. And now we need to find out what the length of one of the sides is. Well, the length of one of the sides of these squares is the difference between these two curves. Or, one way to think about it, the area of our square is the square root of x minus 1/8 x squared squared. So the integral that we're going to want to set up from 0 to 4 and that is exactly what we're looking to find out. The integral from 0 to 4 of the square root of x minus the lower function, the red function, which is 1/8 x squared. Now, we could do this by hand. We could take the whole page and figure all this out. I would like to show you what this looks like in Desmos, just so you have this tool in your toolbox. And so we're going to pull up Desmos side by side. I'm going to take a few little not shortcuts here, but some notation things here. Our first function, we're going to call it f of x equals the square root of x. Boom. And let's go ahead and make it blue just so it matches our diagram. Great. And then we have our second function. I like to use g of x equals, let's see, 1/8 x squared. And we are going to make this one red to match our picture. Great. So here is the same picture that we have. And we are just going to set up this exact integral that we found. So we can actually type in this entire situation. Capital V equals. The integral function, you can either go to the keyboard and type in int, or you can go to functions, miscellaneous, and there's our integral symbol here. We're going to go from 0 to 4. And instead of, I mean, you could type in the square root of x and 1/8 x squared over again. Or if you use this f and g notation, you can just type in f of x minus g of x. Put the squared outside the parentheses, and you'll notice a number is not coming up yet, but that's because we haven't typed dx. And believe it or not, my friends, that is exactly the number we're looking for. So we would put like an approximately here, and we would say 2.057 units. And if you know what you're doing, we still had to use our brains and our calculus knowledge to set up this problem, but once you've set the problem up, and if a calculator is allowed, which in many cases it will be, you can jump right to this step here. As long as you've shown the people grading the AP tests what your equation is and how you found your area, that's all you need to show. All right. My friends, this is our last video. Thank you for being here with me today. Thank you for being here with all three of us all year long. Again, the three of us are so proud of you, and we hope you do well. If you have any questions, be sure to ask. You can leave a question in the comments on the YouTube video, or ask your teacher in class. Thanks, everybody. It was great to talk to you. See you soon.